Hello, welcome to a new session on Python programming, offered by Sifting Bytes Academy. My name is Venu, and in this video, we will learn about various Python versions that are available for us in Python's official website. Python Software Foundation is the organization which oversees the development of Python language. It maintains a website, python.org, the official website for Python. And this is where we should go to download Python and install it in our system. If we go to the downloads page, we can download the latest version of Python for our operating system. Mine is Windows as detected by the website. If yours is a different operating system, then the website will show an appropriate version for your system. Now instead of clicking on the button, I'll click on the Windows link down here to check out the other versions available for Windows. In here, we can notice few things, like various Python versions. But the common thing is how they are numbered in a specific format. Observe that it's in the form of x.y.z. We will try to understand this format in this video. Also notice there is something called latest release, there are stable releases, and then there are pre-releases. What are they and what's the difference? We will learn about them in detail in this video. This will give us a better idea on choosing the right Python version for our environment. I hope you find it interesting and informative. Let's get started. Just like any other language, Python has evolved from the time it was first released to the current version. It was published for the first time in 1991, labeled with a version number 0.9.0. Python reached version 1.0 in 1994. Since then, the language has evolved phenomenally with the addition of new features and enhancements. Python 2.0 was released in 2000, and then Python 3.0 was released on 2008. Notice that standard Python follows a specific versioning format which is actually in the form of x.y.z. Python 2 and Python 3 are just shortcuts, easy to remember names. Now there is a reason why this style of formatting is adopted for labeling Python versions. The best way to understand this is by taking an example. Please bear in mind that approximate version numbers and dates are taken just to demonstrate this formatting technique. Because remembering exact version numbers and dates are not important, but the concept is. So, let's say Python 1.0.0 released in early 1994. Here, 1 is the major version number, 0 here is the minor version number, and this 0 is the patch version number. In general, it's in the format x.y.z. Now just like any other software, Python is not without any bugs. There is nothing called a bug-free software. More bigger the software, more is the scope for bugs. So, identifying bugs and fixing them is pretty common in software industry. Let's say Python community found few bugs in Python version 1.0.0. A bug fix is defined as an internal change that fixes incorrect behavior. After fixing them up, a new version of Python can be released by incrementing the number in the z's place. Here, in this case, from 0 to 1. So, the new patch version is Python 1.0.1. A new version with just some small number of bug fixes can be called as a patch version. New patch versions are backward compatible. That means, if a developer has written a Python code, and if it worked on Python 1.0.0, it will definitely work on Python 1.0.1. So, it's safe for a developer or a system admin to update Python installation in their computer. Existing code or applications would just work fine like before. And in fact, it runs even better as there is lesser scope for bugs. But remember, the patch version, that is, the number in the place of z must be incremented only if backwards compatible bug fixes are introduced. This process of bug fixing can happen multiple times. It pretty much depends on how many bugs are discovered. And every time they fix them up, patch version number is incremented and released. And let's say it evolved to maybe Python 1.0.7 by the end of the year 1994. At this point, the Python community has realized that it is time to add some new features and functionalities to the language. New but backward compatible minor features and functionalities. In this case, the new version will be released by incrementing the minor version number in the vice place. The new version number is Python 1.1.0. And note that the patch version must be reset to 0 when minor version is incremented. New minor versions are also backward compatible. That means if a developer has written a Python code and if it worked on Python 1.0.7, it will definitely work on Python 1.1.0. So, it is safe for a developer or a system admin to update Python installation in their computer. Existing code or applications would just work fine like before. On top of it, new code can be written now by taking advantage of these new features and functionalities. Let's assume there have been few bug fixes to this minor version later, which eventually led to Python 1.1.14. And later on, few more minor features are added to the language, which led to the evolution of Python to 1.6.1 in late 2000. Now let's say at this point, the Python community has felt the need to do some major changes to the language. This major update should be represented by incrementing the major version number in the X place. New major version could be Python 2.0.0. Note that patch and minor versions will be reset to 0 when a major version is incremented. These major changes to the language might or might not make it backward compatible. That means if a developer has written a Python code and if it worked on Python 1.6.1, it might or might not work on Python 2.0.0. So, it might not be safe for a developer or a system admin to update Python installation in their computer to this new major version. Existing code or applications might or might not work the same way they did before. Developers might have to make some code changes to make them work again. Amount of rework they need to do depends on what kind of new changes have been incorporated. But in the case of Python 2.0.0 major release, it did not break anything. It was backward compatible with earlier versions of Python. With bug fixes and feature enhancements, the language continued to evolve to Python 2.6.9 in 2008. That's also when some major changes were done to the language and released as Python 3.0.0. And it's very important to note that this major version was not fully backward compatible. So, some pieces of code in already existing applications wouldn't work. And changes had to be done to the code to make them work in Python major version 3. In fact, there was a divide in the Python community about what kind of changes are to be done to the language. One section of the community felt the need for major updates to the language by adding in new radical features even though they were not backward compatible. Another section of the developer community recommended a conservative approach and wanted to add in new features gradually to the existing 2.6.0 branch so that it wouldn't break the existing application's code bases. Hence, developments to the language happened actively in both the branches, Python 2 and Python 3, until a final release of Python 2, Python 2.7.18 on April 2020, which marked the end of life of Python 2 branch. And most of the community has moved on to Python 3 at this point now. Let's pull up the Python's official website again to check out the various available Python versions. In here, we can see 4 types of releases in general: latest releases, stable releases, pre-releases, and older releases. Let's start with latest releases. As it's in the name, these are the most recent versions that have latest features added to the language. One can download and install them in their personal computers to learn and explore these new features. These features have been developed, tested, and added into the language after going through an elaborate development cycle. After the development cycle is completed, the latest version is released for developer community to use. But in spite of going through an elaborate process in which it is thoroughly tested by Python core team, since it is recently released to general developer community, there are chances of discovering new bugs that the Python core team might have missed catching. Hence, these are not suitable for production systems right away. On discovering bugs, they will be fixed and new patch version will be released. This is an ongoing process until lesser and lesser bugs get reported, and at that stage, the version is considered to be stabilized a bit. Here, we can see the latest releases of Python 3 branch as well as Python 2 branch. When recording this video, the latest release in Python 3 line is Python 3.10.4 and the latest release in Python 2 line is Python 2.7.18. As on today, there is no reason for anyone to use Python 2 because most of the projects and applications have migrated to Python 3. So, if someone is stuck working on some sort of legacy application which is still using Python 2, then they can download this latest version of Python 2 and explore it. And also, they should seriously consider and plan migrating to Python 3 as early as possible. There are also stable releases. Again, as it's in the name, these are the versions which have been out there for quite a long time. So, with a series of bug fixes, it has now stabilized a lot and are hence suitable for production environment. Python.org also maintains older versions of Python just in case if anyone needs one. And then there are pre-releases. Pre-release versions are the ones that are released while the development of the version is still going on. Every release goes through an elaborate and a well-planned development cycle. Let's take an example of the latest release of Python 3, which is 3.10.4. So, bug fixes happened 4 times since minor version 3.10.0 released in October 2021. Every version, before it is released, goes through a well-planned development cycle. Python's core team draws out this detailed cycle plan way before they actually start working on it. In general, there are 3 phases: alpha phase, beta phase, and release candidate phase before the final release, which is the final release that would be released to the public. In the case of 3.10.0, it was planned to have 7 releases in alpha phase, 4 releases in beta phase, and 2 releases in release candidate phase. These releases are made available for public so that professional Python developers from Python community can also test them and report if they find any bugs. So, they are kind of early developer previews of Python 3.10.0. We can download and install it in our personal computers to test them. We can also report any bugs in these versions of Python to the Python issue tracker available in python.org website. So, all these pre-releases or preview releases are basically testing versions. Hence, they are not recommended in production settings. Alpha release previews are intended to make it easier to test the current state of new features and bug fixes, and also to test the release process. During the alpha phase, new features may be added, and if necessary, those newly added features may also be modified or deleted. If deleted, they would never make it to beta phase. Beta release previews are also intended to give the wider community the opportunity to test new features and bug fixes, and also to prepare their projects to support the new feature release. During the beta phase, new features cannot be added, but if necessary, those features may be modified or deleted. If deleted, they would never make it to the release candidate phase. Release candidate previews are the ones in which only very minor code changes are allowed, maybe to allow some bug fixing. But major changes to the code are not allowed. New features cannot be added in this phase. In the next video, we will dig a little deeper on how to choose a version for our environment. We will try to understand various environments that we will be working in by taking a real-time scenario. That's all for now. See you in the next one. Your feedback will be enormously helpful in improvising the final shape of this course. So please subscribe to the Sifting Bytes channel and contribute any questions, comments, or suggestions in the comment section below. Thank you.